Massive stones have outlasted entire empires. Ancient builders created cities that still stand after thousands of years, and they did it all without a single computer or modern machine. This video reveals the sophisticated engineering secrets that granted these structures their incredible immortality. You will learn the precise principles of material science and urban design that we have forgotten, knowledge that could revolutionize how we build today. How did the Romans formulate a concrete that grows stronger in seawater? What hidden design in Incan walls allows them to dance during an earthquake and never fall? The answers are a testament to human ingenuity. By the end, you will see these ancient ruins not as decaying relics, but as masterclasses in sustainable construction. What forgotten wisdom from the past do you think we need most for our future? Timelessness in architecture was never about simply building something heavy and hoping it would last. It was an active, dynamic conversation between a structure and the world around it. Ancient master builders operated on a core principle that we often ignore today. A city must become a symbiotic part of the landscape, not a conqueror of it. This was a profound shift in perspective. They did not see a hill as something to be leveled, but as a foundation to be married to. They did not see a river as a threat to be walled away, but a partner to be channeled. This philosophy was often encoded in practices we might call geomancy or sacred geometry, where alignments with stars or solstices were meticulously planned. To our modern scientific eyes, these rituals reveal a deep, functional wisdom. Aligning a city with the path of the sun was not just ceremonial. It was a brilliant method for optimizing solar gain, providing natural warmth in winter and cool shade in summer. Positioning a main street to catch prevailing winds created a natural ventilation system, pulling fresh air through the entire settlement. This was a holistic design philosophy that seamlessly wove together geology, hydrology, and climatology into a single, unbreakable fabric. The choice of where to place a temple was a calculated scientific decision. They sought out the solid, unyielding bedrock, not just for symbolic strength, but for a stable foundation that would not shift. The very shape of a wall was often curved or angled not for mere aesthetics, but to dissipate the immense energy of an earthquake or a hurricane, allowing the force to flow around the structure rather than through it. They viewed their cities as living, breathing organisms, each part serving a purpose in a greater whole. This foundational mindset, this reverence for the forces of nature, is the first and most crucial secret to their permanence. And to bring this visionary philosophy to life, they needed to turn to the very earth itself, crafting materials that were anything but primitive. This mastery over materials, this alchemy of stone and mortar, began with a simple but profound truth. Ancient builders did not fight their environment for resources. They became partners with it, transforming local earth and stone into composites so advanced they defy our understanding of age. The Romans created a concrete that was not merely resistant to the sea, but was invigorated by it. Their secret was a specific volcanic ash mixed with lime and rubble. When this blend met seawater, a slow chemical miracle unfolded. Crystals of a mineral called tobermorite grew within the matrix, actually filling any microcracks that formed over time. The concrete did not erode. It healed itself, becoming denser and stronger with each passing century. This was a material designed for eternity. Far across the world, the Maya developed their own sophisticated recipe. They burned limestone with specific types of tree bark and sap, creating a lime plaster that was more than just a glue. The organic compounds acted like a natural polymer, giving the plaster a flexibility that pure lime lacks. This binder could absorb slight shifts and stresses without shattering, creating surfaces that were both beautiful and remarkably durable. But the material itself was only half the story. The true genius was in the assembly. Look at the stonework of the Incas or other master builders. They selected stones not just for their size, but for their innate compressive strength. Then they shaped each one into a unique, irregular polygon. When fitted together, these stones locked into place, their complex, jigsaw-like edges distributing weight and force evenly across the entire wall. In an earthquake, a rigid, mortared wall would crack and crumble, but these interlocking stones could dance. They would shift and sway, settling back into their original positions once the trembling stopped. This was not crude stacking. It was a precise engineering art where every single block was a custom-shaped puzzle piece, and the entire structure was a unified, flexible entity. The longevity of these materials forces us to look beyond their composition to the intelligence of their assembly. Understanding the components is one thing, but grasping the master plans that organize them, the visionary layouts that turned individual stones into immortal cities, is the next critical step. Moving a stone the size of a small building required more than just brute force. It demanded a symphony of logistics, where every step from quarry to foundation was a masterclass in applied physics. Take the legendary trilithon at Baalbek in Lebanon, where 3 stones, each weighing over 800 tons, were somehow transported nearly a kilometer. The journey began at the quarry, where builders displayed an almost surgical understanding of the rock itself. They did not simply carve out blocks. They read the stone, identifying natural fracture lines and weaknesses. By driving wooden wedges into these cracks and then soaking them with water, the expanding wood would cleanly split the granite or limestone along a near-perfect plane. This was not mining, it was a form of geological persuasion, turning the landscape's own structure into the primary tool for harvesting. Once freed, the true challenge began. How do you shift a mass equivalent to 2 fully loaded jumbo jets across uneven ground? The solutions were brilliantly low-tech yet devastatingly effective. Workers would construct wooden sledges and run them along tracks made of greased timbers. They might have used a mixture of water and clay as a lubricant, creating a slippery surface that drastically reduced friction. Teams of laborers, coordinated by rhythmic drums or calls, would then pull on ropes, inching the colossal load forward. Some researchers suggest that for the most unimaginable weights, ancient engineers might have employed a more esoteric method. Legends from various cultures speak of using specific chants or acoustic frequencies to seemingly lighten stone. While it sounds like myth, the concept of harmonic resonance is a real physical force. Could precise sound waves have been used to create a standing wave that partially counteracted gravity, or to vibrate the lubricated track into a near-frictionless state? The idea remains controversial, but it highlights the depth of their potential knowledge. The sheer investment in this process, moving mountains one stone at a time, tells us something crucial. These were not just building materials, they were sacred, foundational elements destined for a grand design. And once these stones arrived at their destination, they were assembled according to a master plan so intelligent that it could predict and withstand the chaos of natural disasters for millennia. The true test of a city's design was not the daily routine, but the sudden, violent storm. When rain fell on the barren mountains surrounding Petra, it did not bring life. It brought a wall of water, rock, and debris crashing toward the city. The Nabateans did not cower from this force. They orchestrated it. They carved the landscape itself into a massive water management machine. Intricate channels, some no wider than your hand, were etched directly into the cliff faces, capturing the initial floodwaters. These channels fed into larger, masterfully sloped conduits that steered the deluge away from the city's heart and into a network of hidden cisterns. In a single downpour, they could capture enough water to sustain the entire population for months. This was hydrological engineering as a form of urban self-defense, a system that turned a desert's fury into its most precious resource. This same foresight echoed 2,000 miles away in the sprawling streets of Mohenjo-Daro. Here, the challenge was not scarcity, but sanitation. Every house was connected to a city-wide grid of covered, baked brick drains. The entire city was laid out on an almost imperceptible slope, a gentle gradient that used gravity to whisk wastewater and rainfall through the streets and out of the city, long before stagnation could breed disease. This was not a luxury, it was a fundamental pillar of civic survival. By preventing water from pooling and seeping into foundations, they eliminated the slow, insidious erosion that dooms so many structures. They understood that a city's longevity depended as much on what flowed out of it as what flowed in. This mastery over water, this ability to make a relentless enemy into a loyal partner, reveals a universal principle. The greatest ancient cities were not static monuments. They were dynamic systems designed to absorb and redirect the immense energies of their environment. And if they could tame the flow of water, they could also learn to dance with the shaking of the earth. The ground itself was the enemy they had to befriend. In lands constantly shaken by earthquakes, ancient engineers did not try to build rigid fortresses against the tremors. Instead, they created structures that could move in harmony with the earth. The Incas perfected this art at places like Machu Picchu and Ollantaytambo. Their walls, built from stones cut with breathtaking precision, fit together without any mortar. This was not a sign of primitiveness, but the very source of their strength. In an earthquake, a mortared wall acts as a single, brittle unit. It cracks under the strain. But an Incan wall is a community of stones. Each uniquely shaped block, with its complex polygonal edges, is locked to its neighbors. When the ground shakes, these stones do not fight the motion. They dance, they shift and sway, absorbing and redistributing the immense energy. And when the trembling stops, they simply settle back into their perfect, interlocked positions. This principle, what we now call a seismic construction, was a brilliant application of empirical physics. They understood dynamics and load distribution through observation and experience, creating a system modern engineers still analyze with awe. This wisdom was not confined to one continent. Far away in ancient Greece, the Mycenaeans faced the same threat. In their monumental tombs, they used a technique known as corbelling. They layered stones, each course slightly overlapping the one below, until the walls curved inward to form a domed roof. This method created a structure that distributed weight and stress evenly in all directions, making it far more resilient to ground movement than a simple vertical wall would have been. And sometimes the secret ingredient was flexibility itself. Many cultures intentionally wove wooden beams into their stone frameworks. This timber lattice, often hidden within the walls, acted as a shock absorber. It gave the entire structure a crucial element of ductility, allowing it to bend and flex without breaking apart. These were not accidental discoveries. They were deliberate, calculated responses to the environmental pressures these builders knew they would face. They designed for the movement from below by mastering the interplay of mass and motion. But to complete their immortal cities, they also had to solve a force that acts from above, the constant, unyielding pull of gravity on their monumental creations. They transformed sheer weight into a source of strength through the silent power of geometry. The most enduring shapes in ancient architecture are not squares and rectangles, but curves and triangles. The Romans perfected this principle with the arch, a form that seems to defy gravity. An arch does not simply hold weight up. It redirects the immense downward force of compression outwards and down along its elegant curve, channeling it safely into the supporting piers on either side. This single innovation allowed them to create vast, airy spaces that previous builders could only dream of. The ultimate expression of this is the dome of the Pantheon in Rome, a structure that has stood for nearly 2,000 years. It remains the world's largest unreinforced concrete dome, a record that speaks to a profound understanding of physics. The builders did not rely on brute mass alone. They engineered the dome to become lighter as it rose higher. The concrete mix at the base was heavy, packed with dense travertine stone. But as the dome curved upward, they changed the recipe, using progressively lighter aggregates like pumice and volcanic tufa. Then they carved the interior ceiling with a pattern of recessed squares called coffers. This coffering was not merely decorative. It removed tons of non-essential material, further lightening the load on the walls below without weakening the dome's structural integrity. This was a masterpiece of calculated weight distribution. A similar, though vastly different, geometric wisdom is etched into the sands of Egypt. The pyramid's perfect triangular shape is the most stable structure possible for such a colossal mass. Each sloping side acts like a ramp, guiding the incredible weight of millions of stone blocks down and inward, focusing that force into the solid bedrock beneath the desert. The precise orientation of its base, aligned almost perfectly with the cardinal directions, ensured that this load was distributed evenly, preventing any one side from subsiding more than another over the centuries. These builders understood that form and force were inseparable partners. By choosing the right geometry, they could make a structure support itself in perfect balance. And this intimate knowledge of the physical world extended beyond the stone and mortar into the very air the cities breathed. The same geometric intelligence that mastered gravity also shaped the very air people breathed. Ancient builders designed their cities as massive, passive climate control systems, ensuring comfort and preserving the structures themselves from environmental decay. In the scorching deserts of Persia, they perfected a structure called the Badger, or windcatcher. This tower rising from a building's roof was far more than decoration. It acted as a natural air conditioner, capturing the cool, prevailing winds from high above the ground and funneling them down into the living spaces below. At the same time, it created a pressure differential that sucked the hot, stale air up and out. A single architectural feature could transform a sweltering interior into a cool refuge without using a single drop of fuel. This principle of thermal regulation was woven into the very fabric of cities. In the ancient city of Janay in Mali, the distinctive mud brick architecture is a masterclass in material science. The buildings feature incredibly thick walls which provide what is known as high thermal mass. Think of these walls like a thermal battery. During the intense heat of the day, the walls slowly absorb warmth, keeping the interior spaces surprisingly cool. Then, when the cold desert night arrives, the walls slowly release that stored heat, warming the rooms inside. This natural cycle created a stable, comfortable environment year-round. Even the layout of a city's streets was a calculated climatic decision. The narrow, winding alleys of many ancient Mediterranean cities were not a result of haphazard planning. They were deliberately designed to create deep shadows, shading the paths from the harsh sun. This layout, what modern urban planners call the urban canyon effect, also served to channel and accelerate cooling breezes, creating a natural ventilation system for the entire community. By working in harmony with the sun, wind, and local climate, these brilliant designs did more than just make life pleasant. they drastically reduced the thermal stress on building materials. The constant expansion and contraction from daily temperature swings is a primary cause of cracks and structural fatigue. By moderating these extremes, the ancient builders added centuries to the lifespan of their creations. This was sustainability in its purest form, creating comfortable living conditions for thousands without consuming any energy beyond the genius of the initial design. This deep, symbiotic relationship with the environment points toward a final, overarching secret, a unifying philosophy that bound every one of these ingenious principles into a single, coherent vision for immortality. For the master builders of antiquity, a city's foundation was laid not just in the earth, but in the stars. The placement of a temple or the orientation of a street was a deliberate act of cosmic mirroring, a way of embedding the perceived order of the universe into the very grid of urban life. This was a world view where science and spirituality were one, and the principles we now call sacred geometry were, in fact, a highly sophisticated language of engineering and astronomy. Consider the staggering precision of the Great Pyramid of Giza. Its base is aligned to the 4 cardinal directions with an error of less than 1/15th of a single degree. Achieving this required generations of meticulous celestial observation, tracking the cyclical motions of stars to establish a true north that had nothing to do with a magnetic compass. This was not an act of religious vanity. A perfectly square base aligned to the Earth's rotation ensured that the pyramid's immense weight was distributed with mathematical perfection, preventing the structure from twisting or shearing over millennia. The geometry was the engineering. This same fusion of cosmos and concrete unfolded on the other side of the world. The sprawling temple complex of Angkor Wat is far more than a collection of beautiful towers. It is a precise architectural model of the Hindu universe with its central mount surrounding mountain chains and outer ocean. But this cosmic symbolism had a profoundly practical purpose. The vast moats and intricate canal systems that define the site were not merely decorative. They were part of a massive hydrological engine. The precise dimensions and alignments of the temple guided the flow of monsoon waters across a vast agricultural plain, turning the symbolic cosmos into a life-giving irrigation machine for an entire civilization. The spiritual blueprint was also a functional municipal water plan. Even the very proportions of their structures held this dual power. The ancient Greeks were masters of the golden mean, a ratio found throughout nature, from the spiral of a nautilus shell to the arrangement of seeds in a sunflower. When they designed their temples using this divine proportion, they achieved more than just timeless beauty. They stumbled upon a fundamental principle of structural integrity. The golden mean often corresponds to the most efficient and stable ways to distribute loads and resist stress. A column's height to its width, the span of a room. These sacred ratios created buildings that were not only pleasing to the human spirit, but were also inherently, physically resilient. This holistic approach, where every line drawn was both a prayer and a mathematical calculation, imbued these places with a significance that transcended their physical function. A building that was seen as a sacred reflection of the cosmos was far more likely to be maintained, repaired, and revered by generations, ensuring its physical preservation through its cultural immortality. This profound connection to the heavens, however, was always grounded in the human community that gave the city its life. The blueprint for an immortal city was drawn not just for stone, but for society itself. Ancient urban planning was a conscious act of weaving function, health, and community into the very streets, creating a resilient social fabric as durable as the walls that enclosed it. In the meticulously organized city of Mohenjo-Daro, one of the world's first grid systems, was a masterstroke of practical wisdom. The planners deliberately separated residential neighborhoods from industrial zones like pottery kilns and metalworking areas. This was a profound innovation in public health. By distancing the smoke, fumes, and fire hazards of industry from the homes, they dramatically reduced the risk of both pollution and catastrophic blazes sweeping through the entire population. This was zoning for survival. Meanwhile, in ancient Greece, the Acropolis of Athens was placed high upon its rocky hill for more than just defense. Its elevated position made it a constant, visible symbol for every citizen below, a unifying force for the city-state's cultural and religious identity. This careful placement fused civic pride with strategic necessity, strengthening the community's will to endure. The design of the streets themselves served multiple, layered purposes. Wide, straight main thoroughfares, like the famous Royal Road in Persepolis, allowed for the efficient movement of armies to quell unrest and for trade caravans to bring vital goods, fueling the city's economy. But just off these grand arteries, a network of narrower, shaded secondary streets and small plazas emerged. These intimate spaces were the city's living rooms, where daily life unfolded, children played, and neighbors connected. This hierarchy of circulation prevented the chaotic, unplanned growth that inevitably strangles a city's infrastructure. A logically organized layout meant that essential systems like water pipes, drains, and roads could be easily accessed, repaired, and expanded. A city that was easy to maintain was a city that could be maintained forever, and the brilliance of this master plan relied entirely on the hidden networks operating silently beneath the citizens' feet. These thriving urban centers understood that true resilience grew from the land itself. While we often picture ancient cities as vast expanses of stone, many were, in fact, living ecosystems where nature and architecture were one. The legendary Hanging Gardens of Babylon captured this ideal perfectly, a vision of terraced gardens rising into the sky, where trees and vines grew not in spite of the city, but because of it. This integration of lush vegetation directly into the built environment was a masterstroke of urban design. It provided cooling shade that moderated the intense heat, reducing the thermal stress on buildings. It cleaned the very air, and perhaps most importantly, it offered a reliable source of fresh food grown within the safety of the city walls. This was not merely about beauty. It was a strategic defense against scarcity. In the heart of Mesoamerica, the great city of Teotihuacan turned its waterways into farmlands through a system known as chinampas. These were not floating gardens in a literal sense, but artificial islands constructed in the shallow lake beds. Builders wove together reeds and stakes, then layered them with rich mud from the lake bottom, creating incredibly fertile plots. Canals woven between these islands allowed for easy irrigation and transportation of crops directly to the city's center. The chinampas produced multiple harvests each year, feeding a massive urban population without relying on distant, vulnerable farmland. Can you imagine the security that provided? A city that could feed itself from its own heart was nearly invincible to siege or regional famine. Beyond the practicalities of food and climate, these green spaces served a deeper human need. Sacred groves and public gardens offered residents a place for respite and community, contributing to the psychological well-being that is essential for any stable society over centuries. This seamless blend of the urban and the agricultural created a circular, self-sustaining economy. It drastically reduced a city's dependency on long, fragile supply lines that could be cut by war or disaster. By weaving farms into their fabric, these cities built a powerful form of independence, and this self-sufficiency was a fortress in its own right. Yet it had to be paired with more direct methods of protection to ensure a city's ultimate survival. A city's walls were far more than a simple line in the sand. They were a psychological statement, a declaration of permanence carved in stone. The legendary walls of Constantinople stand as the ultimate example of defensive engineering. This was not a single barrier, but a complex, multi-layered system. Attackers first faced a wide, water-filled moat. If they crossed that, they met a low outer wall where defending troops could harass them. Beyond that rose the monumental inner wall, a colossal structure over 12 meters high and 5 meters thick, studded with nearly 100 towers. Each tower acted as an independent fortress, allowing defenders to pour crossfire onto any enemy that reached the base. The genius was in the staggering depth. A besieging army had to break through not one, but 3 separate defensive lines, all while under constant attack from above. This system resisted every assault for over 1,000 years, protecting the heart of an empire. But sometimes the best defense was the land itself. Look at Machu Picchu, perched on a razor-backed mountain ridge high in the Andes. The Incas did not just build on this natural fortress. They enhanced it. Steep agricultural terraces cascaded down the slopes, but these were more than just farms. They formed a series of nearly vertical, impossible-to-scale barriers. Any attacking force would be exhausted and exposed long before they reached the city's core. The entrances were deliberately narrow, designed as deadly funnels where only a few warriors could pass at a time, easily neutralized by a handful of defenders. This was intelligent design that turned geography into a weapon. Every element was calculated. Curved gateways prevented the use of battering rams. Parapets and crenellations provided cover for archers. The very approach to the city was often a long, winding path up a steep incline, forcing an enemy to advance slowly and in single file, completely vulnerable. A city that could not be conquered was a city whose knowledge, culture, and architectural secrets remained intact, its legacy passing uninterrupted from one generation to the next. But the most enduring cities understood that true immortality required more than just physical barriers. It demanded a fortress of the mind, a legacy so powerful it could not be erased. The most resilient walls were those built not just around a city, but within its culture. Ancient architects knew that stone alone could eventually crumble, but a structure woven into the identity of a people could achieve a different kind of immortality. They turned their grandest buildings into massive, three-dimensional libraries, etching their deepest beliefs and greatest stories directly into the facade for all time. Walk through the halls of an Egyptian temple, and every column and wall surface tells a story. Those intricate hieroglyphs and detailed reliefs were far more than art. They were a permanent public record of divine order, pharaonic law, and historical triumph, carved with the explicit intention of lasting for eternity. They ensured that the principles governing their society would outlive any single ruler or generation. This was architecture as a direct line to the future. The sheer, overwhelming scale of monuments like the Pantheon or the Colosseum served a similar psychological purpose. Their grandeur was a deliberate statement designed to inspire a sense of awe and submission. When a citizen stood in the shadow of the Colosseum, they felt the immense, unshakable power of Rome. When a pilgrim approached the Pantheon, they witnessed the glory of Athena and the Athenian state. These structures were physical manifestos, declaring that the institution they represented was as permanent as the mountains. This created a powerful cultural inertia. A temple seen as the home of a god or an amphitheater that was the heart of civic life was not simply a building, it was a sacred symbol. This profound connection motivated generation after generation to preserve it, to repair its walls after an earthquake, to clear its stones of encroaching vegetation. The community itself became the ultimate preservation society, crowdsourcing the maintenance of its cultural soul across countless lifetimes. A building that is cherished, that holds a people's memory, is a building that is saved from neglect and oblivion. This deep cultural investment, however, was often supported by a foundation of remarkably sophisticated scientific knowledge, proving that their wisdom was both spiritual and profoundly practical. Behind every immortal stone was an even more durable mind. The master builder was a living library of applied science, a figure who blended the roles of architect, geologist, and astronomer into one. This knowledge was not public property. It was a closely guarded treasure passed in strict secrecy from mentor to apprentice within powerful guilds. Think of the medieval cathedral builders whose traditions later influenced groups like the Freemasons. Their craft was a sacred trust, a collection of hard-won secrets accumulated over centuries of trial and error. They did not guess, they knew. They knew which quarry yielded the most resilient limestone. They understood the precise mixture of sand, lime, and ash that would create a mortar stronger than the stones it bound. They could calculate the perfect angle for an arch using only a knotted cord and geometric principles. This was not just a job, it was a sworn duty to uphold an unbroken chain of wisdom. To ensure this precision could be replicated across a project that might last 100 years, they relied on standardized measurements. The Egyptian royal cubit, a rod of black granite measuring just over 20 inches, was the absolute standard for the pyramids. Every single block, every corridor, every chamber was measured against this single, unvarying length. This guaranteed that work done by one crew of stonemasons would fit perfectly with the work of another crew that might not even be born until decades later. The master builders held the keys to the machinery of construction as well. They designed complex systems of ramps, winches, and counterweights that multiplied human strength, allowing small teams to maneuver colossal weights. They kept secret the astronomical charts used to lay a temple's foundation stone at the exact moment it was aligned with a specific star, ensuring the entire structure was literally grounded in the cosmos. This concentration of expertise was the ultimate quality control. It meant that every decision was based on a principle that had already been proven to work for 1,000 years. There was no room for risky innovation when the goal was eternity. When these guilds eventually faded away, often dissolving into history, their unique, unwritten knowledge vanished with them. We can only look at the structures they left behind and wonder at the depth of understanding we have lost. To truly grasp their genius, we must see these principles in action, etched into the stone of their greatest achievements. Deep beneath the windswept plains of Cappadocia lies a world reversed. The city of Derinkuyu descends 18 stories into the earth, a labyrinth of living quarters, stables, and churches all carved from the soft volcanic tuff. This was not a temporary hiding place. It was a complete, inverted metropolis designed to protect 20,000 souls from any threat the surface could muster. The entrance to this subterranean fortress was guarded by a brilliant piece of engineering, massive, circular stone doors. Each one weighed nearly half a ton and could be rolled shut from the inside, sealing corridors like a stone vault. In the event of an attack, these barriers could isolate entire sections of the city, forcing any intruder who breached the first door to fight through a deadly, claustrophobic maze. Yet the true genius of Derinkuyu was not in keeping people out, but in sustaining life within. How do you keep a population of thousands breathing comfortably hundreds of feet underground? The answer was a network of over 50 ventilation shafts. These meticulously carved chimneys ran from the deepest chambers all the way to the surface, disguised as simple well openings. They created a constant, gentle flow of fresh air, driven by the natural temperature difference between the cool underground and the warmer surface air. This passive system prevented stagnation and removed smoke from cooking fires, ensuring the atmosphere remained clean and breathable even during a siege that could last for months. The city tapped its own water supply from deep, protected wells, drawing from the same water table that fed the surface, but securing it from contamination or enemy poisoning. The surrounding rock itself acted as a perfect natural insulator, maintaining a constant, mild temperature year-round. While the surface baked in summer heat or froze in winter storms, life underground continued in stable comfort. This environmental control did more than just keep people alive. It preserved the entire structure, as the absence of freeze-thaw cycles and extreme thermal expansion prevented the soft stone from cracking and eroding. Derinkuyu stands as a masterclass in defensive foresight, a community that found its ultimate strength not by building upward, but by digging inward. While the master builders of Derinkuyu mastered the earth, the Khmer engineers of Angkor learned to command the sky itself. Their capital was a hydraulic empire, a civilization built on the precise control of water across a vast, seasonal landscape. At the heart of this achievement was the West Barre, an artificial reservoir of almost unimaginable scale. 8 kilometers long and 2 kilometers wide, this was not a mere pond. It was a colossal inland sea, entirely hand-excavated, capable of holding over 50 million cubic meters of water. This reservoir was the beating heart of a city-wide circulatory system. A meticulously engineered network of canals, moats, and smaller reservoirs branched out from it like arteries and veins, reaching every corner of the urban sprawl. During the intense monsoon season, this system acted as a massive relief valve. It captured the torrential rains that would have otherwise flooded the city, channeling the deluge safely into the storage basins. Then, when the long, punishing dry season arrived, the process reversed. The stored water was gradually released through the canals to irrigate thousands of acres of rice paddies. This was the genius of the Khmer water grid. It transformed a landscape of extremes into a perennial agricultural powerhouse, guaranteeing not just one, but often 3 full rice harvests every single year. That consistent surplus of food did more than just prevent famine. It funded an empire. It freed up a massive labor force, an army of workers who could be dedicated not to mere survival, but to the construction of the most majestic temples the world has ever seen, including the legendary Angkor Wat. The temple itself was not an isolated monument. It was the central node in this grand hydrological design. Its vast moat was not just symbolic. It was a massive stabilizing reservoir, helping to regulate the water table beneath the temple's immense weight and prevent subsidence. The entire city was a single, integrated machine. Modern satellite imagery and aerial laser scans have revealed the true extent of this planning, showing a sprawling, low-density urban grid perfectly centered around these water features. The roads, the temples, the neighborhoods, all were laid out in relation to the life-giving canals. This makes the city's eventual decline all the more poignant. After centuries of stability, the region was struck by periods of extreme climate variation, including prolonged droughts followed by intense, catastrophic monsoons. The very system that had sustained Angkor for so long may have become its vulnerability. The intricate canals and reservoirs, designed for a different climatic rhythm, could have silted up or overflowed their banks, disrupting the agricultural base that supported the entire society. The fall of Angkor stands as a powerful testament. It shows that even the most brilliant engineering is a dialogue with the environment, and when that balance is lost, the stones themselves can falter. Venice did not conquer its lagoon. It learned to float upon it, When its first builders arrived on those marshy islands in the 5th century, they faced an impossible task. How do you erect a city of marble and stone on a foundation of mud and water? Their radical solution was to build a forest underwater. They drove thousands of wooden piles, each one made from dense alder wood, deep into the soft, compressed layers of clay and sand beneath the lagoon's floor. These were not mere stakes, they were the roots of a city hammered in until they hit the stubborn, solid stratum far below the unstable silt, and then something remarkable happened. Submerged in the waterlogged, oxygen-poor mud, the wood did not decay. Instead, it began a slow transformation. Without oxygen to feed the microbes that cause rot, the wood fibers mineralized over centuries, hardening into a stone-like substance. This petrified forest became an immovable grid, a hidden skeleton upon which the entire weight of Venice would eventually rest. But a stable foundation was only the first challenge. The lagoon's water itself was a constant threat, prone to stagnation that could breed disease and foul the air. The Venetians did not see the water as an enemy to be walled out. They designed their entire city as a machine to work with the tides. The canals were not just picturesque streets, they were the engineered veins and arteries of a living system. Their specific widths, depths, and placements were calculated to harness the natural ebb and flow of the Adriatic Sea. With each tide, millions of gallons of fresh seawater would surge through the canals, flushing out waste and stagnant water, scouring the channels clean, and circulating oxygen to sustain the lagoon's delicate ecosystem. This was a self-cleaning city powered by the moon and the sea. The very stone foundations of the palaces, laid upon that petrified wooden grid, were built with another brilliant adaptation. The stones were not set directly against the wood. Builders used a layer of dense, waterproof Istrian stone as a plinth, a barrier that resisted the corrosive saltwater and rising damp. This understanding of materials, from the water-hardened alder deep in the mud to the salt-resistant stone at the waterline, reveals a profound partnership with the environment. They did not force the lagoon to suit their city. They engineered a city that was an extension of the lagoon itself, a breathtaking achievement in humility and hydrodynamics that allowed a dream to take root in a place where no city should logically stand. They did not simply build their structures and hope for the best. They sealed them with a chemical armor developed through centuries of deliberate experimentation. The Romans, masters of this applied chemistry, perfected a brilliant waterproof shield. They would coat their formidable walls and monuments in a fine, polished stucco, a mix of lime and powdered marble. This created a seamless, gleaming white surface that was far more than decorative. It acted like a raincoat for the entire building, shedding water efficiently and preventing moisture from seeping into the core masonry where it could freeze, expand, and crack the stone from within. But for an even tougher defense, they turned to the kiln. They developed a specialized plaster called coxiopsto, made by mixing lime with finely crushed terracotta tiles and pottery. This gave the plaster its distinctive reddish hue, seen on countless Roman ruins. The secret was in the fired clay. The crushing and heating process created microscopic, plate-like particles that overlapped within the plaster matrix, forming a dense, interlocked barrier that was exceptionally resistant to penetrating dampness. This was a calculated defense against the specific challenges of their climate. On the other side of the world, in the humid atmosphere of Delhi, stands an even more startling metallurgical marvel. The iron pillar of Delhi has defied one of nature's most relentless forces, corrosion, for over 1,600 years. It should be a crumbling mass of rust, yet it remains remarkably pristine. The secret is a paper-thin, invisible protective film called mesawite. This compound of iron, oxygen, and hydrogen formed on the pillar's surface during its unique forging process, which involved a high phosphorus content and very little sulfur. The local atmospheric conditions then worked with this special alloy over time, allowing the stable, protective layer to develop and mature. This coating is so stable and adherent that it prevents the oxygen and moisture in the air from reacting with the pure iron beneath, effectively putting corrosion into a state of permanent arrest. These ancient engineers were not just builders, they were material scientists who understood that longevity required a proactive, multi-layered strategy. They tailored specific chemical solutions to combat the unique environmental threats each structure would face, treating preservation not as an afterthought, but as a fundamental principle of the design itself. The true scale of these timeless cities reveals another hidden layer of genius, one that operated not in stone but in society. To build for eternity, ancient leaders first had to master the art of mobilizing humanity itself. The construction of the Great Pyramid was a national project that required the precise coordination of tens of thousands of people. This was not an army of slaves as Hollywood might suggest, but a highly organized workforce composed of skilled artisans, stonemasons, and farmers who worked during the inundation season when the Nile flooded their fields and farming was impossible. These workers were not expendable labor. They were valued state employees housed in purpose-built villages with bakeries, breweries, and medical facilities. Archaeologists have uncovered evidence of set bones and healed injuries, proving they received sophisticated care. Imagine the logistical operation required just to feed this city of builders. Every day, thousands of loaves of bread and jugs of beer had to be produced, while cattle, sheep, and goats were driven in from across the kingdom to provide protein. This was a supply chain that stretched across Egypt, all managed without a single sheet of paper or digital ledger. Their administrative system, relying on hieroglyphic records and a class of expert scribes, tracked every bundle of rope, every copper chisel, and every sack of grain, ensuring this colossal project never stalled from a lack of resources. A similar, though different, system powered the Inca Empire. They employed a rotational labor tax known as the mitre, which required every household to contribute a certain amount of time to state projects. This was not a crushing burden, but a shared civic duty that efficiently mobilized millions of workdays each year. A farmer might spend a season helping to build a stretch of the royal road or a new set of agricultural terraces, knowing that his own community would benefit from the labor of others in return. This system created a powerful sense of collective ownership and shared investment in the empire's infrastructure. The ability to coordinate such vast human resources over decades, and sometimes even centuries, is perhaps the most overlooked engineering secret of all. It ensured that a project started by one generation would be finished by the next, with no drop in quality or vision. The administrative mind that could plan for a century was as crucial as the architectural mind that designed the arch. This deep-time project management required a stability and a shared purpose that we can scarcely comprehend today, a cultural commitment to a future its builders would never see. The secret to immortality was not rigidity, but a profound and inherent flexibility. A city designed for a single purpose would die with that purpose, but the ones that endured were those that invited reinvention. They were built with a robust, almost skeletal framework that could be clothed in new cultural skins again and again. The Hagia Sophia stands as the ultimate testament to this principle. Its massive dome and soaring spaces were conceived for Christian worship, yet its architectural power was so universal that it seamlessly transformed into a grand mosque, its structure effortlessly accommodating the addition of minarets and Islamic calligraphy. Today, as a museum, it serves a third, entirely different civic role. The building itself was never the end goal. It was a magnificent, adaptable vessel, ready to be filled with whatever meaning a new era demanded. This capacity for rebirth extended beyond individual buildings to the very bones of the city. For centuries, the marble-clad monuments of the Roman Forum were not treated as untouchable ruins. They were seen as a vast, open-air quarry, a source of pre-cut, high-quality stone known as spolia. Medieval builders and later Renaissance architects would carefully dismantle ancient temples and basilicas, carting away their columns and carved blocks to construct new churches, palaces, and fortifications. A piece of a 2nd century temple might live on as the cornerstone of a 10th century church and later be incorporated into a 15th century wall. The original structure was gone, but its physical essence was recycled, its strength and beauty granting longevity to generations of new creations. This continuous cycle of reuse prevented these urban centers from becoming frozen in time. They avoided the fate of a static relic, instead remaining dynamic, living entities that constantly evolved. The most powerful element of this adaptability often lay beneath the streets. The foundational infrastructure of roads, aqueducts, and city grids often proved to be so perfectly efficient that they became permanent. Countless modern European highways trace the exact, unerringly straight lines laid down by Roman surveyors 2,000 years ago. The logic of their routes, bridging rivers and piercing through mountains, was so sound that no successor civilization ever found a good reason to change it. They simply paved over the ancient stones and kept moving. A city that could not change was a city doomed to be abandoned. But a city whose core was designed for endless reinterpretation, whose streets and structures welcomed new life, could truly achieve forever. Their grandest monuments sometimes stand as tombstones for the very landscapes that made them possible. The enduring legacy of these ancient cities is not just a story of engineering triumph, but also a profound lesson in the consequences of breaking a pact with the local environment. On the remote expanse of Easter Island, a society that erected the mysterious Moai statues ultimately collapsed, not from war, but from a slow, self-inflicted ecological disaster. To move their massive stone figures across the island, they required vast quantities of strong timber for rollers and sledges. This led to the systematic and complete deforestation of their entire ecosystem. With the trees gone, the soil eroded, and the land could no longer support the agriculture needed to feed the population. The very act of building their cultural icons destroyed the foundation of their survival. Their brilliant engineering for monument transport completely overlooked the sustainability of the resource it depended upon. A similar pattern of environmental overreach may have sealed the fate of the magnificent Maya city-states. Their decline coincided with periods of intense, prolonged drought, but their own practices likely made this natural challenge catastrophic. To fuel their growing urban centers and feed their populations, the Maya cleared vast tracts of forest for agriculture and to create plaster for their buildings, a process that required burning enormous amounts of wood. This widespread deforestation may have altered the local climate, reducing the rainfall that was already becoming scarce. They were caught in a vicious cycle where their solution for growth undermined their resilience to climate change. These stories force a difficult reflection. Even the most advanced engineering, the most perfectly cut stone, cannot forever compensate for a fractured relationship with the surrounding world. The ultimate engineering secret is not found in a single wall or aqueduct, but in the creation of a holistic, sustainable system where the city's demand for resources exists in a long-term balance with the environment's capacity to replenish them. The stones of these fallen cities ask us a pressing question for our own time. Are we building systems that will stand for 1,000 years, or are we, like them, consuming the very foundations of our future in the pursuit of our present? The wisdom of ancient builders is no longer confined to ruins. It is being reborn in the steel and glass of our modern cities, as architects turn to the past to solve our most pressing contemporary challenges. The principles that granted structures immortality are now being recognized as blueprints for a sustainable future. In the deserts of the Middle East, the ancient windcatcher, or badger, has found a new life. Modern buildings are incorporating sophisticated ventilation towers that function on the exact same principle, capturing high-altitude breezes to cool interiors without a single watt of electricity, drastically reducing the energy demands of air conditioning in some of the hottest climates on Earth. This is not mere historical homage, it is a validation of a timeless logic. The same is true for the ancient understanding of thermal mass. The thick, mud brick walls of old, which slowly absorbed heat by day and released it by night, are the direct ancestors of the massive concrete floors and walls in today's green buildings. These modern materials perform the same thermal battery function, stabilizing indoor temperatures year-round and slashing the need for fossil fuel-powered heating and cooling systems. This is passive design at its most elegant, and it was mastered thousands of years ago. Perhaps the most urgent application of this ancient knowledge is in how we confront the shaking Earth. In earthquake-prone regions like Japan and Peru, engineers are actively studying the polygonal, mortar-free stonework of the Incas. They are developing modern construction methods that incorporate similar principles of flexibility, creating buildings with joints that allow them to sway and dissipate energy rather than resist it rigidly. This biomimicry of ancient engineering proves their solutions were not primitive. They were profoundly efficient, sustainable, and resilient. By decoding these secrets, we are not just uncovering history. We are accessing a vast library of proven, low-tech, high-efficiency solutions. The bridge between a 2,000-year-old wall and a future-proof city is shorter than we ever imagined. This connection forces a fundamental question about our own path forward. We now hold the power to resurrect these ancient cities digitally, preserving their genius long after the last stone has turned to dust. A technology called LiDAR, which stands for light detection and ranging, is our modern X-ray vision. By firing millions of laser pulses from an aircraft, it can pierce through the densest jungle canopy, mapping the ground beneath with centimeter-perfect precision. This is how we discovered the true scale of Angkor, not as an isolated temple complex, but as a vast, low-density metropolis with suburbs, canals, and roads sprawling across an area the size of modern Los Angeles. Entire cities, lost for centuries, are now revealing their secrets without a single tree being cut down. But what about sites that are too fragile to touch, or those tragically damaged by war or earthquakes? Here, three-dimensional modeling and virtual reality build a new kind of time machine. We can strap on a headset and walk the vibrant, painted streets of ancient Rome, or stand in the very center of a Babylonian temple, hearing the echoes of rituals performed thousands of years ago. These are not just video games, they are precise scientific reconstructions, data-rich models that allow archaeologists to test theories about how a space was used or how light fell on an altar at the summer solstice. The preservation goes even deeper into the very physics of the structures themselves. Engineers now use sophisticated software to perform digital autopsies on monuments. They can simulate the fury of a 1,000-year earthquake, applying immense forces to a virtual model of an Incan wall to watch, in real time, how each interlocking stone shifts and settles, revealing the precise mechanics of its dance. They can model wind loads on a crumbling cathedral or calculate the groundwater pressure threatening a buried tomb. This digital resurrection does more than create a backup copy of history. It captures the full engineering blueprint, the complete DNA of a building's resilience. Even if the original finally yields to time, its lessons, its very soul, is granted a new and permanent life. This fusion of past and future unlocks a revolutionary possibility. What if we could apply these timeless principles not just to preserve the old world, but to construct a new one? For all our sophisticated tools and digital models, the stones themselves still guard fundamental secrets. The inner chambers of the Great Pyramid are a perfect example of this frustrating gap in our knowledge. We can theorize about ramps and levers to explain the outer blocks, but the king's chamber is built from immense slabs of granite, a rock so hard it can only be cut with diamond-tipped saws today. These blocks were shaped and polished to such perfection that the joints between them are barely visible, with tolerances of less than a single millimeter. How did they achieve this flawless finish with simple copper chisels and stone tools? The logistics are equally baffling. These granite monoliths were quarried over 500 miles away. Transporting them that distance, then hoisting them precisely into place over 150 feet up inside the pyramid's core, presents a puzzle that dozens of theories have failed to conclusively solve. It is a humbling reminder that a project managed on such a colossal scale could also achieve a level of microscopic precision that rivals our own. On the other side of the world, in the jungles of Costa Rica, another geological mystery sits silently. Scattered across the landscape are hundreds of massive stone spheres, some over 6 feet in diameter and weighing several tons. They are almost perfectly spherical, their surfaces smooth to an uncanny degree. Who made them and for what purpose? Were they astronomical markers, symbols of status, or part of a grand cosmological map we can no longer read? The even greater mystery is how they were shaped. The local granite is full of fractures, yet these spheres show no signs of tool marks. Did the builders use a combination of controlled heating and cooling to spall off layers of rock, followed by years of painstaking polishing with sand? Without any written records or tools left behind, their creation remains an open question. Then there are the mysteries you can hear. In certain underground temples on Malta and deep within the pyramids of Mesoamerica, specific chambers possess extraordinary acoustic properties. A single spoken word can create a powerful resonance that fills the entire room, vibrating through the stone and the very bones of the listener. These are not accidental echoes. They are the result of a deliberate design where the dimensions of the room, the curvature of the walls, and the specific frequency of sound were all calculated to interact. This suggests that these cultures understood the physics of sound waves, using resonance to alter states of consciousness during rituals or to amplify a priest's voice into something supernatural. We are only now using sensitive equipment to measure these effects, realizing that their knowledge of this invisible force was perhaps as advanced as their mastery of stone. These persistent enigmas are not failures of modern science. They are its lifeblood. They prove that the ancient master builders still have lessons to teach us, and that the quest to understand their world continues to reveal hidden depths in our own. Every stone laid was a declaration of belief. The sheer ambition of these projects was fueled by forces more powerful than any machine, the deep human needs for meaning, power, and remembrance. A pharaoh did not commission a pyramid simply as a tomb. It was his celestial launchpad, a machine engineered to propel his soul to the realm of the gods, while its impossible scale on earth served as an undeniable billboard of his divine right to rule. The tons of limestone and granite were not just building materials, they were the physical substance of his immortality. paid for by the state's entire economy and assembled by a populace united in a common spiritual endeavor. Half a world away, the rivalry between Greek city-states played out in marble and devotion. Athens did not build the Pantheon merely to house a statue of Athena. They built it to proclaim their cultural and political supremacy over every other polis, especially Sparta. It was a statement written in the most expensive stone, on the most visible hilltop, screaming to the world, "Look at our wealth, our sophistication, our direct line to the gods." This competitive piety drove an arms race of architectural magnificence, each temple more refined and glorious than the last, pushing the boundaries of engineering and art. This powerful convergence of faith, pride, and power created an unstoppable social engine. It justified the decades of labor, the vast consumption of resources, and the relentless pursuit of perfection. A community building a cathedral in medieval Europe saw it not as a construction project, but as a collective prayer in stone, a tangible offering to God that would bring blessings to their town for centuries. This shared cultural investment guaranteed that these structures were not just built, they were cherished. They became the heart of a community's identity, ensuring that generation after generation would feel compelled to maintain, repair, and defend them. The engineering secrets gave the stones their physical resilience, but it was this profound human spirit that gave them a soul, making them worthy of preservation long after the empires that built them had turned to dust. The final, breathtaking truth is how all these elements converged into a single, unified blueprint for eternity. Their stones whisper a final, unifying secret across the centuries. The true masterpiece was not any single wall or aqueduct, but the holistic philosophy that wove them all together. These builders achieved immortality through a profound partnership with the natural world, a deep understanding of physical forces, and a cultural commitment to a future they would never see. Their genius was not magical, but intensely practical, born from centuries of observing the world and learning its rhythms. They knew that a city must bend with the earthquake, not resist it. They knew that water must be channeled as a partner, not fought as an enemy. They understood that the geometry of a dome could make it float on air, and that the orientation of a street could cool it with the wind. This was an empirical science, tested and refined over generations, encoded into traditions and guild secrets passed from master to apprentice. Perhaps their most powerful lesson, and the one we struggle with most today, is their long-term vision. They built for a legacy spanning hundreds, even thousands of years, a timescale that dwarfs our modern planning cycles. The silent pyramids of Giza, the stone-clad streets of Petra, and the misty peaks of Machu Picchu are far more than picturesque ruins. They are timeless textbooks, each chapter written in granite and limestone, teaching us that resilience is found in harmony, intelligence, and a humble respect for the forces that shape our world. Let their enduring presence inspire us to construct a future that is not only technologically dazzling, but also profoundly wise, resilient, and truly worthy of lasting 1,000 years. We would love to hear which ancient engineering marvel speaks most deeply to you. Share your thoughts in the comments below and subscribe to join us as we continue unraveling the great mysteries of our shared human past.